All right, let's learn about the sine and cosine ratios of our trigonometric ratios, section 9.5. So our objectives are to use the sine and cosine ratios, find the cosine and sine of angle measures in special right triangles, and solve real-life problems involving the sine and cosine ratios. Our essential questions: how is a right triangle used to find sine and cosine of an acute angle? And is there a unique right triangle that must be used? Some important terms to know is sine. It's a trig ratio of an acute angle of a right triangle involving the ratio of opposite leg and hypotenuse. The cosine is a trig ratio of an acute angle of a right triangle involving the ratio of an adjacent leg and hypotenuse. So that's the main difference, is sine uses opposite leg and hypotenuse. Cosine uses adjacent leg and hypotenuse. And then just to refresh your memory on our abbreviations, we must remember, here they are one more time. So take a moment to jot them down in your new notes. Our trig ratios compare two sides of a right triangle, and every acute angle has a specific trig ratio. In other words, we will never use our right angle. All right, let's see our first ratio for today, so our sine ratio. Let triangle ABC be a right triangle with acute angle A. The sine of angle A, written as Sin for short, is defined as follows. Sine of A is equal to the length of the leg opposite angle A divided by the length of the hypotenuse. So if this is the picture, and this is angle A, then the leg opposite would be BC. So BC divided by hypotenuse, which is AB. And we can shorten this all down to sine theta, so whatever our angle is, equals OPP divided by hypotenuse. In other words, S equals O divided by H, and the word so is part of the mnemonic that we can use to help us identify which trig ratio. So far we have TOA for the tangent and SO for sine. Next we have our cosine ratio. Again, right triangle with the acute angle A. This time cosine of angle A is defined as follows. It's the length of leg adjacent to angle A, which is going to be AC, divided by the length of the hypotenuse, which is AB. Shortened down to cosine of theta equals adjacent over hypotenuse. So here's part of our mnemonic, ka. So now we have all three. So, ka, toa. Our sine, cosine, and tangent ratios, SOHCAHTOA. And I've got a story for you involving Chief SOHCAHTOA. All right, let's just practice finding the sine and cosine ratios of angle S and R. Write each answer as a fraction and as a decimal rounded to the 10,000th place. I'm going to fix that. There we go. It's the 10,000th place, which is 4 place values. All right, let's start with sine of S. So here's angle S, and sine is opposite divided by hypotenuse. So here's my opposite, and here's my hypotenuse. So I would be getting the length of RT divided by the length of SR. Substitute my values, so 63 divided by 65. I type that ratio in the calculator, so type in 63 divided by 65, hit enter, and you should get 0.9692. Now let's do the cosine of S. Cosine of S involves the adjacent side. So adjacent would be side ST divided by hypotenuse, which would be SR. Substitute your values, type it in the calculator, divide 16 by 65, you should get decimal 2462. Now let's switch over to the other acute angle, and that's R. So the sine of R, this time we want opposite of angle R. So I've switched to a different color. So opposite of R would be 16. And hypotenuse is hypotenuse, no matter which angle you're looking at. So it would be ST divided by SR. So we would plug in our numbers, 16 divided by 65, and that's what you type in the calculator. So type in 16 divided by 65, hit enter, and you should get decimal 2462. Now we're going to figure out cosine of r. Cosine of r would be adjacent. Adjacent this time is RT divided by SR, which is our hypotenuse. So 63 divided by 65, type that in your calculator, and you should get decimal 9692. Hopefully you notice there's a pattern. We have decimal 9692 for both the sine of S and the cosine of R. And then we have decimal 2462 for both the sine of R and the cosine of S. So we have the opposite going on here. Kind of interesting. All right, that pattern we just noticed leads us into our next core concept. Essentially, sine and cosine of complementary angles. The sine of an acute angle is equal to the cosine of its complement. Just a quick reminder, complement simply means to subtract the number we're given from 90. The cosine of an acute angle is equal to the sine of its complement. So opposite, sine goes with cosine, and then sine goes with cosine. So essentially, whatever angle you're given, subtract it from 90, and then do the opposite. So the sine of A is going to be the cosine of B, the complement of A. Cosine of A is going to be sine B. B is the result of getting the complement of A. And same over here. So write all these down, take a moment. All right, so let's practice with rewriting trig expressions. So write sine of 56 degrees in terms of cosine. So that means get the complement of 56, and we're going to use the fact that the sine of an acute angle is equal to the cosine of its complement. So that just means subtract 56 from 90, so you should get 34. So sine of 56 is equal to the cosine of its complement, which means it's equal to cosine of 34 degrees. Now look both those values up on your chart and see if you have a match. Also type them in your calculator and see if you have a match there too. And just a quick refresher, now when you select your trig functions, you're going to choose sine or cosine for today's lesson. All right, let's find leg lengths of the following 26-degree angle that we're given. So we put my theta symbol right there. All right, so we're looking for opposite and adjacent. And then we're given the hypotenuse. So labels are important. All right, so we'll have two setups. One will be the sine of 26, which equals opposite divided by hypotenuse, and the other setup will be cosine of 26 degrees, which equals adjacent over hypotenuse. So which one of these is going to help us solve for x, and which one's going to help us solve for y? Hopefully you guessed correctly. The sine of 26 will help us solve for x, and cosine of 26 degrees is going to help us solve for y. All right, so let's start with solving for x. So substitute what we know for opposite, which is labeled x, and hypotenuse, which is labeled 14. Now we're going to solve for x by multiplying both sides by 14. And when we do that, we get 14 times the sine of 26 degrees. That's exactly what you type in the calculator. Hit enter. So the value of x is about 6.1. For our other setup, we would substitute y for adjacent and 14 for hypotenuse. And to solve for y, we would multiply both sides by 14, getting y by itself. Therefore, that's exactly what you type in your calculator. 14 times cosine of 26 degrees, hit enter, and you should get a y value of 12.6. Now let's find sine and cosine of a 45-degree angle. So just do a quick sketch of your right angle and label the 45-degree angle. And then for your legs, put 1s, which means your hypotenuse is square root of 2. So sine would be opposite over hypotenuse. So if this is our angle, then opposite would be 1, and hypotenuse would be square root of 2. And since we can never leave radicals in the denominator, we have to rationalize the denominator. So square root of 2 gets multiplied both the numerator and denominator, resulting in square root of 2 divided by 2. So your exact answer would stay square root of 2 divided by 2. You could type that in the calculator to get the decimal value. And then cosine of 45 degrees would be the adjacent, which would be 1, divided by hypotenuse, which is square root of 2. Now you can never leave radicals in the denominator, so you rationalize the denominator, multiplying both square root of 2 in the numerator and denominator, resulting in square root of 2 divided by 2. That would be exact. Type that in the calculator, you should get decimal 7071. All right, and then our last new vocabulary is going to be angle of depression. The angle of depression is that downward line of sight that you make with a horizontal line. So if you were to put your arm straight out in front of you in line with your eye, like we did today in class, that would be your horizontal line. And now take your other arm and just rotate it downward towards some object you might be looking at on the ground, or if you're up on a cliff, you could be looking down below the cliff at some object. So that angle formed between your left arm that you're making horizontal with the ground and in line with your eye, and the arm that you're making go downward towards some object below you, your line of sight, that angle formed is called an angle of depression. So let's look at this example. You're skiing on a mountain with an altitude of 1,200 feet. In other words, you're 1,200 feet above sea level. The angle of depression is 21 degrees. So find the distance x you ski down the mountain to the nearest foot. So let's make sure we identify this angle of depression correctly. Your angle of depression is this angle here, because your line of sight is going out horizontal to the ground, and then as you look downward towards the bottom of the slope. So your angle formed here is your angle of depression. So your angle of depression is 21 degrees. So to solve for x, we would have to use sine ratio. And we're using sine ratio because in relationship to that 21 degrees, so that's our angle there, we have opposite and hypotenuse is what's unknown, because your right angle is up here. So once your line of sight ends, and then your altitude's always perpendicular to the ground. So that means your right angle is here. Then substitute what you know, which is altitude 1,200, that's your opposite leg, and then x is unknown, that's the hypotenuse. So cross multiply, so x gets cross multiplied with the sine of 21 equals 1,200. We're trying to get x by itself, so we need to divide both sides by sine of 21. So we undo the sine 21 on this side, which means we end up with 1,200 divided by sine 21 on the right side. So that's exactly what you type in your calculator. So your decimal value comes out to be 3,348.5. That means you ski about 3,349 feet down the mountain. All right, that's all for today. Sine and cosine. We'll practice these trig ratios in class tomorrow.